This will be our introduction to oxidation, reduction, or redox type reactions. These are a very important type of reaction. It's a reaction that's keeping you alive every day. So a very, very important reaction type. There are some terms that first off we need to memorize and be able to apply. The first is oxidation, and oxidation is an increase in the oxidation number, which is the way we used to learn it, but the more current thing is to think of it as a loss of electrons. Reduction is a decrease in oxidation number or a gain in electrons. So those two things are indicating the same thing, right? Because for our oxidation number to increase or to become more positive, that means we're losing electrons. For our oxidation number to decrease or become more negative, that means we're gaining electrons. The other two terms are what are called a reducing agent and an oxidizing agent. So reducing agent is the species that's oxidized. Whoever is oxidized is the reducing agent, and that means it's the one donating electrons or it's the loss of electrons. The oxidizing agent is the species that is reduced or the one that is accepting electrons. So we will practice looking at oxidation and reduction reactions and identifying who's being oxidized, who's being reduced, who's the reducing agent, and also who is the oxidizing agent. But let's quickly, before we get into that too much further, let's kind of look at what we're talking about when we talk about oxidation or reduction here. So if we had a elemental copper and it became a copper cation, we know that it does that by losing electrons, right? If we lose electrons, we become more positive. So this would be an incidence of oxidation there. The thing we have to recognize is not only is mass conserved, but charge is conserved as well, because right, this is telling us we're losing 2 electrons. Where are those electrons going? So our oxidation number here for an elemental atom is going to be 0. So on this side of the arrow, we have a 0 charge. On this side, we have a +2. So we need a 0 charge on both sides of the equation. So if we write the 2 electrons over here, we have 2 -1s and a +2. So we have a 0 charge on this side and a 0 charge on that side. So we have the same number and type of elements on both sides of the arrow, but also the same charge on both sides of the arrow. So we have a +2 -1 gives us a 0 charge. Here we have a 0 charge. So another example that you might see is if you had iron 2 and it became iron 3. Right, so our oxidation number is going up. That means we have to be losing electrons. Here we have a +2 on this side of the arrow. Here we have a +3. So we have to add a -1, add 1 electron to this side to balance the charge on both sides of our arrow. Right, and so we're doing a loss of electrons as oxidation. What a reduction looks like. If we had silver cations and they were coming out of solution to become silver atoms, neutral silver atoms, you can see on this side of the arrow we have a +1 charge here. Silver is elemental, so it has a 0 charge. So we have to add an electron on this side to add a -1 charge. So we have a -1 and a +1, 0 charge, 0 charge. So this silver cation is gaining an electron. You can see its oxidation number is going from +1 to 0. So this is an example of a reduction. If we had something like copper or carbon with a 2+ charge and it was becoming elemental carbon, it's elemental, so it has a 0 oxidation number. If you're having trouble with oxidation numbers, go back and watch the video on oxidation numbers. Here we have a 0 charge, here we have a +2 on this side of the arrow, so we add 2 -1 charges. Now we have a -2 and a +2, so 0 charge, and that's a reduction. So the way we remember this, people usually go Leo, Ger, right? So loss of electrons is oxidation, Loss of electrons is oxidation, gain of electrons is reduction. So that's your little lion saying Leo says grr. You know, if you're a parent out there, one day you might have to pretend this is the greatest Father's Day or Mother's Day gift you ever received, but it'll help you remember this Leo grr here.